Hi. So the question that or the concept that we're building up towards is the concept of instantaneous rate of change, or how fast is something moving or changing at an exact, precise moment. And we don't have a lot of tools yet to talk about this, but something we do have rules to talk about are the rate of change of things over a period of time. And we're going to use that concept to highlight what instantaneous rate of change means. So let's suppose we have a rocket that we fire into the air and it shoots up at time equals zero. It hits its peak in 2 seconds at 20 meters and then falls to the ground. And the height is described by minus 5x squared plus 20x meters, where x is the number of seconds after we're fired. And the question we want to answer is, all right, how fast is it traveling upwards at the moment we fire this thing off? And like I said, we don't have a lot of rules for talking about that yet, but a question we could answer is, how fast does the rocket travel on average in the first, let's say, 3 seconds? So what happens in the first 3 seconds? Uh, at the 0th second, you are of course on the ground, and we can highlight that, and we can say, all right, in 0 seconds you're on the ground. What's happening in 3 seconds? In 3 seconds, you're going to be 15 meters off the ground. And so, what what's the rate of change over this period of time then? Well, the way we could look at that is to say, well, in 1, 2, 3 seconds, we've traveled upwards by 15 meters. And so, if I look at the line, if I look at the line connecting these two dots here, this this line here has a slope of 15 divided by 3. This line has a slope of 5. So let me be explicit about that. This thing has a slope of 5, and so over this period of time, on average, the rocket traveled 5 meters per second upwards. That way, after 3 seconds, it travels 15 meters. Well, that's all and good, but it doesn't quite answer the question that we have. So I could ask myself, all right, what happens as a in the first 2 seconds instead? Well, in the first 2 seconds, we go from zero on the ground to 20 meters in the air in 2 seconds. So if I look at this, I could say, oh, well, in the first 2 seconds, my average rate of change was 10 meters a second because in 10 seconds, 2 seconds, I've traveled 20 meters, so I must have moved 10 meters per second. And we can't calculate a slope when B and A are the same as each other, but what I can do is I can keep moving B closer and closer to A. So I can ask, oh, in 1 second, how fast did I travel? Well, in 1 second, I went up 15 meters. So my average rate of change in the first second is 15 meters per second. In the first half second, in half a second, I went up 8.75 meters. So my average rate of change is 17 and a half meters, and so on. 0.25, a quarter of a second. In the first quarter second, I went up 4.688 meters. In a quarter second, that gives me a average rate of change of 18.75 meters. And we noticed that, we went from 5 to 10 to 15 to 18 something, but these changes are getting smaller and smaller. In the first fifth of a second, I'm traveling at 19 meters per second on average. In the first tenth of a second, it's 19 and a half meters. In the first uh, hundredth of a second, it's 19.95 meters. In the first thousandth of a second, it's 19.995 meters. In the first 10,000s, 100,000s, thousands, so on. As we keep doing this, we'll see that these values, they don't just get arbitrarily large, they get closer and closer to some value. In this case, the value looks like it's 20 meters per second, and that's the thing we're looking for. We're looking for the limit of this expression as b goes towards a, i.e. the value that this quotient here approaches.